Hello guys, welcome to chapter 8. Chapter 8 is all about three-dimensional figures. Today we're going to take a look back at some 7th grade skills that you might need a refresher on. How to find volume of some simple prisms. So remember, volume is the measurement of the space inside of a 3D shape. The units used to label a volume are the three-dimensional, so it'll be units to the third power, units cubed, or cubic units, written that way. So they won't use the word units, they'll use the word centimeters or meters or inches or feet. So it'll say something like inches cubed or cubic meters. Those are ways you can label your answers with the proper units. We're going to look at prisms today. A prism is a three-dimensional shape with two congruent parallel bases. Sounds kind of scary. Congruent means they're equal. Parallel means they are not intersecting. And they're the bases of the shape. It's two equal ends, and they're going to be connected by rectangular faces. We'll see what that means in a minute. To find the volume, let's scroll up a little bit. To find the volume of any prism, what you're going to do is you're going to find the area of the base shape. A shape could be a square, could be a rectangle, a triangle, a pentagon, a circle. It could be lots of different things. And in the formula, we call this capital B. Yes, that's a capital B on purpose. Capital B stands for the area of the base shape. What you do with that is you multiply that by the height of the prism. The height can be confusing on some of these prisms. The height is the distance between the two bases. So how far is it from base to base? If the prism's standing up on its base, that's easy. It's just how high is it? Sometimes the prism's going to lay down, and the height won't be up and down. The height will be sideways. So the formula is going to look like this. Volume V is equal to capital B, area of the base, times H, the height of the prism. But since you can have different shapes as bases, squares, rectangles, triangles, pentagons, circles, etc., you're going to have a different formula for different prisms. It's all going to be based on the formula to find the area of the base shape. So for example, a rectangle or a square, you could do length times width. But a triangle, you're doing base times height divided by 2, or 1/2 times base times height. So that's going to change this part of the formula. Let's just show you a couple of simple prisms. Here we've got a rectangular prism. This is the easiest one. Rectangular prism, you've got rectangle here and rectangle back here in the back. Those could be the bases for front and the back. Or you got rectangle down here on the bottom, see me tracing that, and rectangle here on the top. Nice thing about rectangular prisms is it doesn't always have to be one face for the base. That's what these are called. They're called faces, not sides. The three-dimensional solid, three-dimensional figure, each of the outsides are called faces. Here's a triangular prism. Here's laying down, see? This is my triangle base in the front and the congruent and parallel triangle base in the back. And therefore, the height of the prism goes between the two triangles. So the height of the prism is actually not going up and down, it's going like front to back in this picture. Pentagonal prism, because the base is a pentagon. Won't see too many of those. We're really worried about these two for now. But then the height of this between pentagon on top, pentagon on bottom, will actually go from bottom to top. Eventually, this is all going to get us to this, which is a cylinder, not a prism, circular prism. It's called a cylinder. The bases are circles. Height goes from bottom to top. All right. I'm going to show you a couple of examples, and I'll be right back. All right. The volume on my video is not working, so I'll talk you through Mrs. Dawson. She's got a rectangular prism here, and she wants to find the volume. I'll move while I talk for her. She's going to say the width from left to right is 4. And she's going to say the height is 3 because it's 3 tall. And she's going to say the length is 9. I'm going to pause it there for a second because she's saying that this bottom is the base. Okay, the base isn't always on the bottom, but in a rectangular prism, you've got a lot of room for error. It's almost hard to get these wrong. So that means that this bottom, which is a rectangle, has a formula to find the area of length times width. So she replaced that capital B with the L times W already in the formula. That's how you find the area of the base, which is a rectangle. And then you're going to multiply it by the height of the prism, which is 3. She's going to throw some numbers in there. I'm going to skip ahead for a little bit. 9 was the length, 4 was the width. That finds the area of the base. And then the height is 3. She does some multiplication real fast. Maybe not so fast. So that means that 9 times 4 times 3 gives you a final answer of 108. She's going to label it the long way. She's going to label it as cubic centimeters. You don't have to write cubic centimeters. You can just write cm to the 3rd power. All right, Mrs. Pena here has a little bit harder of a problem. She's got a triangular prism. Triangular prism because this triangle and this triangle are the bases. That means that the height between them, the height of the prism, is going to go along this bottom, or equally along the top. They'll both be 16 centimeters. The problem is going to come with this letter H in height. This is the height of the prism. That's part of our main formula. But to find the area of this base triangle, we need a height of a triangle. So the height of the triangle is 10. That's the height of the triangle to find the triangle area. This is the height of the prism to find the volume. I'll let her work this out a little bit. So the volume is equal to the area of the base times the height of the prism. The area of the base, which in this case is a triangle, and H is the height of the prism. She's going to redraw it. Instead of laying down, she's going to stand it up. I don't think that's necessary. In fact, I think that could be more confusing. But here it is over here. She's labeling all these things to equal these. Okay. So she's going to go ahead and instead of doing it in one big step, she's going to find the area of the base by itself first. That base is a triangle, so she's going to do 1/2 times the base times the height. You could also do the base times the height divided by 2. It'll get you the same answer. All right. Let's see her work it out. She's talking about the difference between this is the height of the triangle, not the height of the prism. 1/2 times the base of that triangle. See, she's going back to the original picture after all. Base of that triangle is 6. The height of that triangle is 10. So she could do 1/2 times 6 and get 3. 3 times 10 is 30. Or she could do 1/2 times 10 is 5. And 5 times 6 is 30. Or she could do 6 times 10 is 60. And half of 60 is 30. You can multiply in any order you want. Now that she knows the area of the base, she's going to use that in the formula along with the height of the prism to find the volume of the entire prism. So the volume of the prism is going to be the area of the base she found, that's 30, times the height, which is 16. So she's going to get 480. She's going to label it as centimeters cubed. All right, there's a couple of worked out examples. I'm going to do a couple for you. I'll be right back. All right, here's what it looks like. Here I've got you a rectangular prism. Rectangular prism, we'll call this bottom the base. So the bottom is 5 by 6, that's a rectangle. And we'll call the 10 the height of the prism. So the volume is equal to the area of the base times the height of the prism. Well, the area of the base is a rectangle, so it's going to be the length times the width of 5 times the 6. And then the height of the prism goes from the bottom to the top the way I have it set up. So the height of the prism is 10. So that means the volume of this prism is going to be 5 times 6, that's 30. 30 times 10, 300. Let's give it a proper label. These are labeled in inches. And because this is a volume problem, it's a cubic inches. Inches to the third power. The volume of that rectangular prism, that box we would call it, is 300 cubic inches. Rectangular prisms, not too tough. They should be able to be knocked right out. Triangular prisms are a tougher one. Triangular prisms, last one, triangular prism. Here's my triangle. On the front, that's my first base. The congruent parallel base is the back. The triangle from here, up, down, and across the bottom. So my triangle has a base of 7.2, and my triangle has a height of 9. That's what I'll use to find the area of this triangle. And then the height of the prism goes between triangle and triangle, so it'll be this line. So this is the height of the prism, that's 3. So volume is equal to the area of the base times the height. Well, the area of the base is a triangle formula, so it's going to be 1/2 of the base of the triangle, 7.2, times the height of the triangle, which goes up here, that's 9, times the height of the prism, front to back, 3. So I will grab my handy calculator, press a few buttons. I have 1/2 times 7.2 times 9 times 3. I get a final answer of 97.2. And I'll give it a label. My label is meters cubed, cubic meters. Again, just be careful of the difference between the height of this triangle and the height of the prism. This number is not 9. This is the height of the prism number. Okay? Just one little sneaky point. This triangle here in the front, that's isosceles. Sometimes they might give you this number and not the height. And you'd have to cut this 7.2 in half and use our good friend the Pythagorean theorem for this right triangle to find the height of that base triangle. Wouldn't that be fun? All in due time. I hope this video helped. Good luck.